Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about literal equations, and we're going to solve each equation for the indicated variable. Equals 6x. Okay, so if I was given g equals 6x, and I needed to solve that for x. Okay? Alright. So what I need to do then is I need to get x by itself. To do that, I can treat g and x are just variables. It can be any number. So I see there's multiplication there between the 6 and the x. Okay? So what I'm going to do is actually divide that by 6. So there's multiplication divided by 6 on both sides, leaving me with x on the right and g over 6 on the left. I'm going to rewrite that. Have x come first because that looks a little neater. X comes first equals g over 6 here. And now I have solved for x by itself. So x is by itself. G is on the right when it's over 6. And since we don't know what number g is, we can't, because it can be any number, right? This is some real number. It doesn't, we don't divide there. So we just kind of leave it separated with division, but don't actually divide the 6 into the g. So our final answer here is just x equals g over 6. Equals 2x minus 2, and we want to solve that for x. Okay? So what I'm going to do is I'm going to rewrite my equation here. Okay? U equals 2x minus 2. And then I need to think, okay, how can I get x by itself? What can I do here? Well, I can add a 2 to both sides. If I add a 2 to both sides, I'm left with a u plus 2 on the left is equal to 2x on the right. Then from there, I know the opposite multiplication is division. I'm going to divide by 2 to both sides, leave me with the x on the right and a u plus 2 over 2 on the left. And now I've isolated x. X is completely by itself. So I can rearrange this, have x come first. So x first here equals u plus 2 over 2. And that would be my final answer. Z equals m minus x. And I want to solve that for x. Well, I'm going to rewrite my equation here. Z equals m minus x. And I need to solve that for x. So I need to isolate x. Well, what I'm going to do here is I'm going to subtract an m to both sides. Z and m are not like terms, so I'm going to keep them separate. Z minus m equals a negative x. Well, how do we get rid of the negative? Well, if I want to get rid of the negative, I can multiply both sides by negative 1, right? Multiplied by a negative 1, right? Not negative subtraction. So if I multiply both sides by a negative 1, that leaves me with a positive x on the right, because a negative times a negative is a positive. But a negative 1 times z is a negative z, and a negative 1 times a minus m is a positive m, and so we have negative z plus m. Okay. Now I can rearrange this to have x come first. So I'm going to write it so x comes first, so it looks nicer because that's the variable we're looking for. So I have x equals a negative z plus m. And now at this point, you can say you're done. I'm good enough with this. Some people would like to rewrite this to have an m minus z, and it's really up to your teacher, but I'm okay with that. And so our final answer here is x equals a negative z plus m. G equals CA. And I needed to solve that for the variable a. Okay? So if I need to solve that for a, I'm going to rewrite my equation. G equals CA here. Okay? Then I need to get a by itself. Well, there's multiplication going on between the c and the a. So opposite multiplication is division. I'm going to divide both sides by c. What that does is it eliminates a c on the right, giving me just an a by itself. And then I have a g over a c on the left. A is already isolated. Fantastic. That's what I was looking for. I can rewrite this to have a come first. So I put the a first here. And I'm left with g over c. I'm going to put that on the right. It's the same thing, just a coming first. It looks nicer. And now I have my final answer. I have a isolated, and that is equal to g over c. Pretty simple. U equals x minus k. I need to solve that for x. Okay, so u equals x minus k. I need to solve that for x. Well, my first step here, I'm going to rewrite this equation so it's by itself, so x minus k here. Then from there is I need to solve for x. So how can I isolate x by itself? Well, to get x by itself, I have to move the k over. And subtracting a k, so opposite of that is addition, so I'm going to add a k to both sides. U and k are not like terms, so I'm going to keep them separate. And we have u plus k, and that is just equal to x. Well, now x is isolated. Fantastic, right? And so I'm going to put x, I'm going to rewrite this so that x comes first, because that looks nicer. And I say that every time, I know. So x equals u plus k, and there we go. X is by itself, it's isolated, there's no way we can simplify this. So our final answer here is x equals u plus k. G equals c plus x, and we needed to solve that for x. Okay? So to do that, I need to get x by itself. So I'm going to rewrite my equation, so that's nice and separated here from the problem. Now I have a positive c there. I need to bring that over to the left. And to do that, I'm going to subtract a c to both sides. That will eliminate the c here on the right, leave me with an x by itself on the right. And then I have a g minus c on the left. Okay? X is isolated, fantastic, working pretty good. And so now I just need to put x by itself. Or sorry, no, it is by itself. I'm going to write it coming first, right? Because that looks nicer. So we have x coming first, I have the g minus c here on the left, and that's it. A very simple problem right here. U equals k over a, and we need to solve that for a. Okay? So we have u equals k over a, we need to solve that for a. So what I need to do then is I'm going to rewrite this equation, u equals k over a, and we're solving that for a, so there's a few ways to go about this. And this one I'm going to multiply a to both sides. And I know what you're thinking, like, wait, no, if you multiply a to both sides, you're just adding a to the other side. I know. But I prefer solving the problem this way. By multiplying a to both sides, I limited my a's there, leave me a k on the left. And then I have a times u, k on the right and a times u on the left. But now it's just one more step, right? I can divide by a u to both sides, and that leaves me with an a on the left by itself and a k over u on the right. And a is already isolated now, and it's on the left-hand side. It already looks nice and neat. And so my final answer here is just a equals k over u. G equals x times c, cross country, if you will. And we need to solve that for x. Hopefully you get that reference. Okay? I'm going to rewrite my equation, g equals xc, x times c. And then what I need to do is get x by itself. So there's multiplication going on between the x and the c, our cross country. So divide by c to both sides, leave me with an x by itself on the right and a g over c on the left. Well, x is already isolated. Fantastic, that's what we wanted. And it's equal to a g over c, so I'm going to rewrite this to have x come first. So x equals g over c, and there we are. That is our final answer. X is by itself, and it's equal to g over c. 12 a.m., not p.m., is equal to 4, and we're solving that for the letter a. Okay? So I'm going to rewrite this, 12 a.m. equal to 4, and know that I need to solve for a. Well, there's multiplication going on between the 12, the a, and the m. To get an a by itself, I'm going to divide the other parts, right? Optional multiplication is division, so actually I'm going to divide by 12 and an m to both sides. What that does is eliminate the 12s, eliminates the m, leave me with an a by itself on the left, and now I have 4 over 12 times m, right? Or 4 over 12m. Well, let's rewrite that here. 4 and 12, well, what's 4 divided by 12, right? That's going to be 3. If I divide both by 4, I have 4 divided by 4 is 1, and 12 divided by 4 is 3. So I can simplify 4/12, the fraction, into 1/3, and then the m stays there. So we have a final answer here of a equals 1 over 3m. Negative 3x plus 2c equal negative 3, and we're solving that for x. Okay? So what I want to do here is I want to rewrite my equation, negative 3x plus 2c equals negative 3. Then I'm going to bring my 2c over, so I'm going to subtract a 2c to both sides. That leaves me here with negative 3x equals negative 3 minus 2c. I now am going to divide by negative 3 to both sides. That leaves me with an x equals, now this is tricky, okay, divided by that negative 3, okay. Well, what if I distributed that, right? So that negative, what if I divided both parts by a negative, right? So I can do that. I can take this negative 3, I'm going to leave the 3 down there, the denominator. But with the numerator, I'm going to divide the negative into this negative, right? So the negative and the negative cancel out, leave me with a positive. So we have a positive 3 here. And then we have negative minus a 2c, right? Minus a 2c there. And that ends up with a positive as well. So we have a positive 2c. So we have 3 plus a 2c over 3. And that is equal to x. And let's rewrite it. I'm going to put the 2c first, because that's the worksheet had there. So we have 2c plus 3. Rearrange that using the commutative property over 3. And there we are. We have a final answer here of x equals 2c plus 3 over 3. Now, if that confused you here, what you also can see is if I had a negative 3 minus 2c, if I pulled out a negative 1, that makes that 3 positive, and that makes pulled out this to be a positive 2c. And maybe that's a little easier to see, and that would be canceled out with that negative that's down below. So that's a little note. You could have done it that way, and that might have helped you see it. But either way, my final answer here is x equals 2c plus 3 all over 3. AM equals n plus p, and we're solving that for a. Solving that for a. So to do that, I have an a times n equals n plus p. I'm going to rewrite that. Then I see there's multiplication there next to the a. I need to get rid of that m, right, to get a by itself. So I'm going to divide both sides by n. Make sure when you divide, you're dividing both parts, the whole thing, n plus the p. A lot of students I see will just like bring it to the n or just the p. Okay? So the m's cancel on the left, leave me with an a by itself on the left, equals, well, none of these are like terms, so I can't combine anything. So I just have this. A equals n plus p all over m, and that is, in fact, my final answer. U equals AK over B, and we're solving that for A. Okay? So we have U equals AK over B, and we're solving that for A. Well, what I needed for us to do is I'm going to rewrite my equation. U equals AK over B, and we're solving that for A. And so here's my my tip, and I'm actually going to there's two ways to do it, and we'll solve them both ways here. So you can either, I'm going to rewrite it a second time here so we can see our two methods here. U equals AK over B. I can first, right here, just multiply both sides by B. Right, multiply by B. Leave me with BU equals AK. Okay? And I think they have a UB as well, so it doesn't matter. Then I need to divide by K to both sides, do it separately. K, leave me with A equals on the right, and BU over K on the left. And so I can rewrite this to A come first, and A equals BU over K. And there we go. Pretty simple, right? Divide by K. Or I can do it all in one step. And this is like another little method if you want to do it that way. So I have K over B here. I can multiply both sides by B over K. Not B over B. Stupid. Right? We're not multiplying it by 1. B over K. And what that does, and there's a little separation here. What that does, eliminates the B's, eliminates the K's, leaving me with an A by itself here. And then I have multiply across the top, BU over K. And so by doing that fraction, it really is like, it's taking these two steps and doing it in one step, and that's up to you on how you want to solve that. I sometimes will solve that way, sometimes I'll do it one step. It really doesn't matter. To me, at least, your teacher might want you to show the two steps, but and there we are. So we have, and I would rewrite it to have A come first. So our final answer here, either way, is A equals BU over K, or UB over K. Really doesn't matter. A minus C equals D minus R, and we're going to solve that for A. Okay, we're going to solve that for a. Well, how can I get a by itself? So what I need to do is I'm actually going to add, well, I'm going to rewrite my equation. A minus c equals d minus r. We're solving for a, so to get a by itself, I'm going to add a c to both sides. Well, there's no like terms here, so we're left with a by itself equals d minus r plus c. Okay? And that's basically it, right? That's basically it. We're done. A is isolated with d minus r plus c. I think the worksheet I have here says we should rearrange and have c come first, c plus the d minus r. It really doesn't matter. If your teacher is nitpicky about that, that's annoying. But either way, both is right, or both are right. So we're left with the final answer here. I use my commutative property and sing c out front, but it doesn't really matter. But the final answer is a equals c plus d minus r. xm equals n I wrote a p, it's np. Okay. N times p, and we're solving that for x. Okay? Well, I'm going to rewrite my equation. Xm equals n times p. And then I need to get x by itself, right? Because that's what it asked me to. Well, there's multiplication going on there. So I'm going to divide both sides by m. That leaves me with an x here by itself equals np over m. And we're actually done. X is already isolated, right? Isolated by itself equals np all divided by m. And there we go. Okay, there's no like terms, nothing to combine. Z equals b plus m over a. And we're solving that for a. Okay? Well, I'm going to rewrite my equation here. Z equals b plus m over a. Okay? Well, to go from there, to get a by itself, I'm actually going to subtract a b to both sides first. That leaves me with an m over a by itself on the right, and I have z minus b on the left. Now, here's where we can do something. Okay? I'm going to multiply both sides by an a. Okay, and I know what you're thinking, like, what are you doing that for? But make sure when you multiply the left side by an a, we put parentheses. Okay, and I'm not going to distribute. What that does is eliminates the a on the right, leaving me with just the m. And I have a times z minus b on the left. Okay? Well, from there, I'm not distributing that a. That would be going backwards. What I'm going to do is actually divide by that whole fraction, z minus b. Why not? I can divide by the whole thing. And what that does, it leaves me with an a by itself, because these cancel. A by itself on the left equals m on the right over z minus b also on the right, right? M over z minus b, and there we go. We have a by itself, and it's isolated, and it's equal to m over z minus b, and there we go. G equals x minus c plus y, and we're solving that for x. Okay? Well, we need to solve for x. So what I'm going to do here is I'm going to rewrite my equation. G equals x minus c plus y. And we can probably do all this in one step. So let's go for it. I'm going to add a c to both sides. And I'm going to subtract a y to both sides individually. That leaves me, well, these cancel, leaving with an x on the right. And then I just have, well, g plus c minus y here on the left. Pretty simple, right? All I need to do now is I'm going to rewrite, have x come first, because that looks nicer. The rest is already isolated, or x is isolated, the rest is just there, we can't combine them. So we have g plus c here minus y, and then we're done. No like terms, can't combine the g to the plus c minus y, and there we go. So our final answer just being x equals g plus c minus y. G equals b minus ca, and we're solving that for a. Okay? So my first step is I'm going to rewrite it. I always do that. Rewrite our equation, g equals b minus ca, and I know I'm solving for a. I'm going to subtract the b to both sides. That leaves me with g minus b on the left equals a negative ca on the right. Then I need to divide by a negative c. Divide by a negative c to both sides, and that leaves me with just a positive a on the right, and I have g minus b over a negative c on the left. Okay? Now I'm going to show you a little trick here. Okay? A little trick. A little note here. What is g minus b? Well, I see that negative, and I think I can distribute that negative up top. So if I take the g minus b, what would happen if I pulled out a negative? So I put a negative 1 on the outside of that. If I pull in a negative, well, g becomes a negative g, and then this becomes a plus b, right? And we can think about it, if I distributed the negative back in, negative 1 times negative g is a positive g, and negative 1 times b is a plus a negative b, which is the same thing as minus b. So I haven't changed the equation, or this little part here, I just made it look different. Well, then I can rearrange this and have negative 1 times b plus a negative g, right? I can do that. Then I can even write that to be negative 1 times b minus g. It'd be the same thing. Okay? So now I have negative 1 times b minus g. It's the same thing as just g minus b up top. And this is a common technique to eliminate a negative in the denominator. And so what that does is I can rewrite this to be negative 1 times b minus g all over negative c, and that's equal to a. The negatives will cancel, make them positive, and I can rewrite this to have a come first, and so we have a equals b minus g over positive c. And I like to do that because I don't necessarily want to have negatives in the denominator, and that would be my final answer. Okay, so that little technique helps, and I like doing little side notes in case you can't do that in your head. Kind of that little part, knowing that hey, I'm doing that over there, and then I'm putting it back in here. Okay. G equals CA minus B, and we're solving that for A. Okay? G equals CA minus B, and we're solving that for A. Well, I'm going to rewrite my equation, G equals CA minus B, and now I need to solve for A. So I'm going to add a B to both sides. That leaves me with a G plus B on the left equals C times A on the right. From there, I'm going to divide by a C to both sides. That eliminates the c's on the right, giving me a by itself. And then there's no like term, so we're basically done here. G plus b over c on the left. I could rewrite this, and I'm going to, and have a comes first, because that looks nice and neat. So I have a equals g plus b over c, and there we are. A very simple, quick problem here. Okay? 2x plus 4 equals x times g, and we're solving that for x. Okay? Well, what I'm going to do here, I'm going to bring my numbers to the right and my variables to the left. Okay? So I'm going to rewrite this, 2x plus 4 equals x times g. And I'm going to subtract a 4 to both sides, and I'm going to subtract an xg to both sides. Okay? So on the right here, I have a negative 4, and on the left, well, they're not like terms, so I'm going to just leave it separate, 2x minus x times g. Okay? So what can we do here? Well, if we pull out an x, there, okay, in doing that, what we're essentially getting is an x on the outside, and we're left with a 2 minus g on the inside. So let's think about that for a moment. If I distributed that x back into the parenthesis, I'd have 2x, right? X times 2 is 2x, and x times g is xg, right? Or x times g. The subtraction sign will still be there. So I'm pulling out an x from both parts, which gives me now the multiplication on the outside. I now can divide by 2 minus g to both sides, and that leaves me with x by itself on the left and a negative 4 over 2 minus g on the right. And from there, we're done, right? We have x isolated, it's by itself, and it's equal to a negative 4 over 2 minus g. G equals 1 plus 2a over a, and we're solving that for a. Okay? Well, first I'm going to rewrite my equation here. I'm going to give myself a little space on the left in case it seems like it's been a little more complicated. So g equals 1 plus 2a over a. So my first step here is I'm going to multiply both sides by a to get a out of that denominator. So by doing that here, multiplying both sides by a's cancel here, leave me with a times g equals 1 plus 2a. Okay? So from there, I'm going to bring my a's over to one side and my numbers to the right. So I'm going to subtract the 2a to both sides. And we don't have any numbers to bring over to the right. And so now I have an a times g minus 2a equals a 1. Okay? Kind of sliding over a little here. So what I need to do now is, since I need to get a by itself isolated, I'm going to pull out an a here. So I'm going to pull out an a, and so I'm going to put parentheses around it and then pull it out. So my next step, I have an a out here, and I have a g minus 2, and that's going to equal my 1. So you see when I'm pulling out that a is isolated, right? It's outside. Well, not really isolated, I guess, but it's pulled out so that if I multiply it back in, a times g is ag, and then a times 2 is 2a, and there's a subtraction there. So if I rewrite that up here, okay, I'm going to rewrite that step here, g minus 2 equals 1. So now I have multiplication going on there between the parentheses and the a. So if I divide by g minus 2 to both sides, I'm left with a by itself and whatever 1 over g minus 2 is. Okay? Well, from there, I have nothing else to do. A is already isolated, it's by itself, and it's equal to 1 over g minus 2. And so now I have my answer. There it is. G equals x minus c over x. And we're going to solve that for x. All right? Well, what I need to do is I'm going to rewrite it over here. So g equals x minus c over x. And we're solving for x. So my first step is to get x out of the denominator. To do that, I'm going to multiply both sides by x. That gives me an xg here on the left equals an x minus c. Okay? Well, now I need to bring all the x's over to one side. So I'm actually going to subtract an x to both sides. What that gives me, I'm going to write my equal sign here, equals that negative c, is I'm left with an xg minus an x. Okay? So an xg minus an x equals a negative c. Well, what happens if I can pull out an x from both parts? If I can pull out an x from both parts here, the x times g and the minus x, I'm left with x parenthesis g minus 1 equals a negative c, right? So I distributed, what you can see, if I distribute that x back across, x times g was xg, and x times 1 is x, and there's a subtraction right there in between. And that's will equal my negative c here. So I'm going to rewrite this over here. X times g minus 1 equals a negative c. And now I need to get rid of the g minus 1, or bring it over to the right-hand side, so I have x isolated. So I'm going to divide, opposite multiplication, a g minus 1 to both sides. That leaves me with an x by itself here, and a negative c over a g minus 1. And there we are. There's our final answer. Now sometimes people have the negative out front here, but it's the same thing. Negative c up here and negative right out front. Okay, so our final answer here, x is isolated, is x equals a negative c over g minus 1. xm, not the radio, just x times m, plus, equals x plus z, and we're going to solve that for x, okay? Well, if I'm going to solve for that, what I need to do is I'm going to rewrite it here, xm equals x plus z, and I'm going to bring all my x's over to one side. So we subtract an x to both sides. I'm really trying to avoid sneezing right now, so sorry if I do. That leaves us with a z by itself on the right, and an xm minus an x on the left. Well, now I see two x's there. I can pull out an x from that part, leaving me with x times m minus 1, and that's equal to my z, which is still there on the right. And you can see that if I distributed this, right, multiply the x back in, x times n is xm, and x times 1 is x, and the subtraction sign is still in between. What that allows me to do here is there's multiplication going on. Opposite multiplication is division. So if I subtract an m minus 1 to both sides, that's going to leave me with x by itself here on the left, and a z over an m minus 1 on the right. And now x is all by itself, it's isolated, and so I have my final answer. U plus ka equals ba. And we're solving that for a. Okay? Well, I want to bring all my like terms together. Okay? So what I'm going to do is we'll say, bring over the a's to the right and the u to the left. So I'm going to rewrite this, u plus ka equals ba. And I'm going to subtract the ba to both sides, and I'll subtract a u to both sides. And what that's going to do is leave me with a ka minus ba on the left and a negative u on the right. From there, I see that there's an a in both parts here. So if I pull out an a from both parts, I'm left with a k minus a b times a on the outside equals a negative u. Okay? So then from there, I'm about to sneeze again. I see there's multiplication. So opposite multiplication is division, so I can divide by k minus b to both sides. And that leaves me with a by itself on the left and a negative u, which I almost wrote like a, I don't know, an a or something. Negative u over k minus b, and there we go. A is all isolated, and so we have a equals a negative u over k minus b, and that is our final answer. U equals kx plus yx, and we're solving for good old x here, the staple. Okay, so I'm going to rewrite my equation here, kx plus yx, and that's equal to u. So I notice that there's an x in both parts here. So my next step is I'm going to pull out an x from both parts, leaving with a k plus y. Okay, so I have k plus y in parentheses times x. Opposite multiplication is division, so I'm going to divide by k plus y to both sides. That leaves me with an x by itself on the right and a u over k plus y on the left. Well, x is already isolated by itself now. Fantastic. So let's rewrite it to have x come first. And so my final answer is just x equals u over k plus y. And there we go. That's our final answer. Equation. U equals 3b minus 2a plus 2. And we're going to solve that for a. Okay, so we're going to get a by itself. Well, this one so far is fairly simple. If I bring my 3b over, I can subtract the, sorry, I'm not doing that step yet. First, come on, Sean. Let's rewrite the equation. So we have u equals 3b minus 2a plus 2. So let's get a by itself. Well, why don't I do this? I'm going to add a 2a to both sides. Let's do it this way first, actually. I like that better. We add a 2a to both sides. And that gives me a 2a plus u equals 3b plus 2. I then can subtract a u to both sides, leaving me with 2a equals 3b plus 2 minus u. Okay? Well, what I can do there is now I set the divide by 2 to both sides, right? It gets me a by myself, right? So I have a is equal to, well, what's left here? 3b plus 2 minus u over 2. And there we go. A is all isolated. It's by itself, and it's equal to 3b plus 2 minus u over 2. Now, some people would argue that you should have the negative u first and make a plus 3b plus 2. Nice and neat. I'm fine with where it is. I guess you put your variables together, but it's all good for this problem here. And so I'm good with a equals 3b plus 2 minus u over 2. Hopefully your teacher is as well. Z equals 9a minus 9 minus 3b, and we're going to solve that for a. Okay? So I'm going to rewrite my equation. Let's make sure I keep my 9's and my a's separated because they do look alike. So I have 9a minus 9 minus 3b. I'm going to bring everything over except for the a. So I'm going to add a 9 to both sides, and I'm going to add a 3b to both sides, and then I'll put it over here, whatever. So we're left with z plus 3b plus 9 equals 9a. Well, there's 9 times a there. Opposite of multiplication is division, so I'm going to divide by 9 to both sides. But make sure when I divide by 9 to both sides, I do it to everything that's over here. Okay? So we're left with an a by itself here, and I have z plus 3b plus 9 all over 9. And there we go. We have a isolated. It's fantastic. It's by itself. And it's equal to z plus 3b plus 9 all over 9. Now, I want to rewrite this, that a coming first, because it looks a little nicer. So I'm going to write it out like this. Z plus 3b plus 9 all over 9. And there we go. That is our final answer. It looks nice and neat and fantastic. G equals 4ca, that's 4 times c times a, minus 3ba, 3 times b times a. And we're going to solve that for a. So I'm going to rewrite my equation here so I have some room. 4ca minus 3ba. So what I want to do actually, this is fairly quick and simple, is I see there's an a in both parts here, and it's subtracted by subtraction. So I kind of break this out of two parts there. So what I'm going to do is I'm going to take out an a from both parts. Now we're leaving with a 4c minus a 3b. Now take a moment to think about that. If I multiply the a back into both parts, I'd get 4ca minus 4,3ba, right? But by pulling it out here, I now have multiplication in A. There's only one A now left, which makes it nice. So now I just need to divide by it. Well, what's inside the parenthesis? 4c minus 3b to both sides. 4c minus 3b. Now, you don't need to put parentheses when you divide it, but I just did. A is by itself to the right, and my left, I just have g divided by 4c minus 3b. And A is already isolated. We're done. All I'm going to do is rewrite this to make it nice and neat and put A going first. So I have A equals g over 4c minus 3b, and then we're good. We're good to go. That's it. That's our final answer. Equation. Negative 3a equal to, negative 3a minus 3. I'm sorry. Got ahead of myself here. Got trigger happy with the equal sign. Minus 3 equals negative 2n plus 3p. And we're going to solve that for the letter A. Okay. So first thing is I'm going to rewrite my equation here. Negative 3a minus 3, don't forget that, minus 2n plus 3p. I'm going to add a 3 to both sides to get A's, try to get A by itself. So I'm going to add a 3 here to both sides. And that leaves me with a negative 3a equals a negative 2n plus 3p plus 3. So now all I need to do is divide by a negative 3 to both sides. And now I'm left with A equals a negative 2n plus 3p plus 3 all over a negative 3. And essentially, we're done. I'm happy with this answer. I think it's a fantastic answer. Some people might have some things different where they want to divide the negative into all parts and it makes that to a negative, this is negative, now positive, this is positive. I don't think it's necessary. I think it's fine the way it is. A is by itself, and there we go. Our final answer is A equals negative 2n plus 3p plus 3 all over negative 3. 4x equals a negative 4r plus 2d. And we're going to solve that for x. Okay? Well, this one's pretty simple. I'm going to rewrite this. Equals 4x equals negative 4r plus 2d, so then I can solve it. I'm just going to divide by 4 to both sides. And I'm left with x equals a negative 4r plus 2d all over 4. Now, one thing we need to think about is, well, is there a way we can simplify this? And yes, there is, right? I see there's a 4 in the denominator, and that's an even number, and there's 2 even numbers up here. So there's a few ways to go about it. Some people like just divide all parts by 2, and you can simplify it that way, and we can do it that way. But what you might want to see on the side here, so you can see what's going on, I'm going to take that negative 4r plus 2d, and up over 4, and I'm going to take the upper part here, the numerator, and I'm going to pull out a 2. And what that does, it leaves me with 2 times a negative 2r plus d all over 4. Okay? So hopefully you can see that little step there, that I pull that 2 out, give me 2 times, parentheses, negative 2r plus d. And if I distribute that 2 back in, I'd get what's written above. But what that does is I see that 2 and the 4 can cross out, and that 4 becomes a 2. And so that simplifies me negative 2r plus d all over 2. Okay? So that's what I'm going to do here. All that step kind of goes on there. Sometimes what people like to see is like, okay, all these can be divided by 2, and they kind of do this quick step, which is essentially the same thing that's going on here. 2, that's a 2, and that just gets eliminated. And so we're left with x equals a negative 2r plus d over 2, and that is our final answer. U equals a negative 2a minus 3 all over ka. And we're going to solve that for good old a. Okay? So I'm going to rewrite my equation over here. So I have some room here. U equals negative 2a minus 3 over ka. Well, I want to get all my a's together, but first I'm going to get out of the denominator. So I'm going to multiply both sides by ka. What that does is help me eliminate the ka's here on the right, and I'm left with a ka times u equals a negative 2a minus 3. Okay? Well, now I'm going to bring my a's together, right? So I'm going to add a 2a to both sides. By adding a 2a to both sides, now remember that multiplication here. I really can write this, let's rearrange that, as a times ku, right? Kau is the same as aku, same thing, plus 2a, and that's equal to negative 3. Okay? So what I can do then, I see there's an a to both parts there. So since there's an a to both parts, if I pull an a out, I'm left with ku plus 2 equals a negative 3. And we can see I can distribute that a across to both parts there, and I get what's written up there, right? AKU plus 2a. So I'm going to rewrite this over here, right? A times ku plus 2 equals negative 3. Well, from there, I know there's multiplication. Obviously, multiplication is division with the parentheses, so I'm going to divide both sides by ku plus 2, ku plus 2. And that leaves me with a by itself equals a negative 3 over ku plus 2. And now I'm done. A is isolated by itself. It's equal to a negative 3 over a ku plus 2.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.